Hello, I am recording this at home on Sunday because I don't know how long my voice is going to last, and so this way I only have to do this lesson once instead of twice in a day, and I'll do my other class. So then I like to talk through 2 lessons instead of 6, and hopefully that will help my voice not go out. I had requests for this special guest. I don't know if she's wanting to. Hey! You want a treat? Oh, look at that. There she is. Harley, say hi. There you are. Oh, look at, look right there. Look at, right here. Oh, no treats yet. Okay, there she is. She's saying hi to all of you. There you go. Good girl. All right, sit. Good girl. You want to do some math? You want to do some math? Yeah? Yes, you do? Okay, we'll do some math. Okay, so this chapter, we are moving on to solving inequalities instead of equations. The nice thing is most of the steps that we used in solving equations are exactly the same steps we're going to use in solving equations. There are a couple things along the way that you'll have to look at and that I'll point out, but overall it's the same process that we used in the last chapter to solve equations. So really quick, an inequality is just another way of saying greater than or equal to, or at least, or less than or equal to. But an inequality is a mathematical sentence that compares quantities. We always read them from left to right. The inequality sign opens to the greater number. Just like hungry alligators, they always want to eat more. So now here are the different symbols. We have less than, so we would say n is less than x. Some examples, something like this. The weight must be less than 20 tons. Height requirements, greater than, n is greater than x. Your height must be greater than 45 inches to ride certain rides. Less than or equal to. So when you see the line under, it means not just less than, but it could also be equal to x. So there are some examples there, and then greater than or equal to. So when you see the line under, that means also and equal to. So we are going to work on solving inequalities. And we solve them, like I said, just like we solve an equation. But let's just first talk about what inequalities are. And these are on page 331 in your book. So this is already filled in for you. But this meaning, we'll just look. This is less than, so 4 is less than 8. 3 is greater than -2, just a quick reminder. -6 is less than or equal to 1. 5 is less than or equal to 5. So we couldn't say 5 is greater than 5 because it's not greater than, but we can use these when we can use the same number. This is true when there is an equal to as well. And then same for greater than or equal to. On page 332 now, you can go there. We're going to have to also graph inequalities. So there is a difference. With equations, we get one number for x. But with inequalities, there's actually a whole bunch, actually an infinite number of solutions for x. So look at this really quick.
To graph the solution set of the inequality, start by placing an open dot at 3.5. For an inequality that includes a less than or greater than symbol, an open dot is used to show that the number is not a solution. Next, draw an arrow from the endpoint. To show that values less than 3.5 are solutions, draw an arrow that points to the left. Consider another example. To graph x is greater than or equal to -1, start by placing the endpoint. For an inequality that includes a less than or equal to, or a greater than or equal to symbol, a closed dot is used to show that the number is a solution. Next, draw an arrow from the endpoint. To show that values greater than -1 are solutions, draw an arrow that points to the right.
So the difference with equations, like when we solve an equation, you would get something like x equals -1. So that means the only answer for x would be -1. But with inequalities, x is any number that's greater than or equal to -1. So how many solutions are there for x? How many numbers are bigger than or equal to -1? Yeah, there's an infinite amount. So with equations, there's one solution for x. With inequalities, there's an infinite amount. It just gives you kind of a range of values for x. So any number starting at -1 all the way to infinity, x can be -1, since this has an equal to, x could be 0, x could be -1/2, x could be 2.1, x could be 5.73289, x could be 5 billion, x could be 100,000 trillion, any number that's greater than or equal to 1. So the difference with equations and inequalities, equations, we have one solution for x, whereas in inequalities we have an infinite number of solutions. And you guys will be not only solving the inequality, but also creating the graph. So it is important that you know how to graph that on a number line. And this just kind of shows you physically what the possible values for x look like, not only in an algebraic form, but also kind of a graphic form. Now these subtraction and addition properties of inequality are the same as the ones we used with equations. So the subtraction and addition property of equality also apply here. So essentially when you add or subtract the same number from each side of an inequality, the inequality remains true. So if you have a is greater than b, then I could subtract the same number from both sides or add the same number from both sides and it would still be true. And then same thing if a is less than b. So basically all this is saying is that just like when we solved equations, you can add or subtract the same number from each side to keep the inequality true. So let's just look at a few examples. This starts on page 333. So if I want to solve x plus 3 is greater than 10, it's really just exactly like solving the equation x plus 3 equals 10. So you still, with inequalities, want to get x by itself. So solving inequalities, solving equations, we want x alone. So we're going to start excuse me, with the subtraction property of inequality. We can subtract 3 from both sides and this inequality will still be true. And we get x is greater than 7. And then the last thing you're going to do is, graph this inequality. So we solve it the same way, and we're going to graph the solution set on a number line. So now the thing you need to remember is that since it's just greater than 7, can x equal 7? No, it cannot. So when it's just greater than, we use an open circle at 7. Okay, well, let me do that. I don't know how this works. Alright, I'm just going to draw it. We use an open circle at 7 instead of a closed circle. And that open circle implies that it cannot be equal to. And then greater than 7 is to the right. All the numbers that are greater than 7 are this way. So here's what your graph would look like. You just have an open circle at 7 and a graph drawn to the right. Oops. Alright, so let's look at another example. Same thing, just decimals. You solve problems with decimals the same way you solve any other problem. This is on page 334. So what would be our first step? If we want to get y by itself, then we have to get rid of this. So again, yes, we subtract 0.4 from both sides. And so we get y equals, oops, this is making me type it all in. It's not allowing me. So we get y is, if we subtract this, then we'll get y on the left is less than or equal to -10 on the right-hand side. And now to graph this on a number line, I'm just going to do this right here. So if we want to graph this on a number line, if you guys are like most of the ones on the homework, they give you the number line. But if you're making your own, it's really okay if you just want to graph 0 and then -10. You don't have to graph like every single point. So if you have to make your own graph, you can do it this way. Now, less than or equal to, do I have an open circle or a closed circle? Yes. So closed circle, and then less than -10, the numbers less than -10 are this way. So we're going to draw our arrow to the left-hand side of that. Okay, so any number in this arrow will work for this inequality. If I plug in -11 for x, it's going to work. If I plug in -12, if I plug in -100 for x, -100 is going to be way less than -9, right? So any of those numbers are going to work for x. Okay, Look at page 335. So this works for subtraction as well. If we're subtracting a number from our variable, then how do I get rid of this? Same as equations, you're right, add 5 to both sides. And then on the left, we get -1. -1, there we go, it's finally letting me put the number in. And on the right, the only thing left is the n, so we've got that. So n, we could say -1 is greater than or equal to n. Now, a couple things about this. You can leave your answer just like this, or if we wanted to have the variable on the left, which makes it a little easier when we are graphing, we could flip this around. So for solutions, this is fine, but when you're making the graph, it's kind of easier to graph it if n is on the left-hand side. So if we want n on the left, we kind of just have to reverse this whole thing. We would say that n is, since this is a greater than, I would have to flip this now, less than or equal to -1. So this and this mean the exact same thing. Okay, either one is an acceptable answer, but this form with n on the left makes it a little easier when we want to make the graph. So now here's 0, here's -1. Open or close circle. Okay, and then arrow goes which way? Yes, to the left, 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 keeps going to the left. Okay, so you guys can sing that there. Feel free to sing that as you're drawing your own arrows throughout the homework. So that is really it for the first section of this chapter. We're going to try some of the check problems together, and you'll do some of these for homework, but it's really same steps as equations, except that it's an inequality, so there's an infinite number of solutions, and you're going to have to make the graph as well. Okay, we'll stop there for this video, and I will see you in class.